You just listened to the dawn of the universe, the very moment of creation itself. While we played just a tiny part of the recording, the original 100-second recording represents the sound from about 380,000 years after the Big Bang until about 760,000 years after the Big Bang. You can find a link to the source in the description below. In this video, we dive into the groundbreaking work of John G. Cramer, who brought us closer to hearing the universe's first echo. John Cramer, a professor of physics at the University of Washington, is not just a scientist. He's a pioneer at the intersection of physics and auditory exploration. Known for his contributions to quantum mechanics, Cramer embarked on a unique journey to convert the echoes of the Big Bang into something we can hear. Let's find out how he achieved this feat. When we think of sound, we think of vibrations traveling through air, water, or solid materials. But in the vast emptiness of space, sound as we know it doesn't travel the same way. Space is a vacuum, lacking the medium for sound waves to propagate. So, how can we talk about the sound of the Big Bang? This question lies at the heart of Mr. Cramer's project. By understanding the early universe's density fluctuations, represented in the cosmic microwave background, Cramer found a way to bridge this gap. The cosmic microwave background is a relic radiation from the Big Bang, acting as a snapshot of the early universe. This afterglow stretches across the entire sky. Cramer utilized this data, focusing on the minute temperature variations that represent the primordial sound waves stretching across the universe. These waves are not sound in the conventional sense, but fluctuations in the density of the universe's infancy. These fluctuations provide a snapshot of the universe approximately 380,000 years after the Big Bang, when photons were first able to travel freely. They originated from quantum fluctuations in the very early universe, magnified by the inflationary expansion of the universe. They are essentially tiny differences in the density of matter across the universe, which over billions of years led to the formation of the cosmic structures we observe today, such as galaxies and galaxy clusters. By scaling these fluctuations down to audible frequencies, Cramer translated the universe's earliest whispers into a sound we can comprehend. The journey from cosmic data to audible sound was no small feat. Cramer started with data from NASA's Wilkinson Microwave Anisotropy Probe, which mapped the cosmic microwave background. He then applied a series of transformations to this data, adjusting the scale of these fluctuations to fit within the human hearing range. This process involved not just a scientific understanding, but a creative touch, ensuring the final sound was both accurate and meaningful. Turning cosmic microwave background data into sound was not without its hurdles. One of the primary challenges was the vast difference in scale between cosmic events and human sensory perception. The original fluctuations were on a scale far beyond human hearing frequencies. Cramer had to creatively downscale these without losing the essence of the data. Additionally, the sheer volume of data required sophisticated algorithms to process and translate into sound. By combining technology with innovative thinking, Cramer and his team were able to overcome these obstacles, creating a bridge between cosmic phenomena and human experience. The result was nothing short of extraordinary. A haunting sound that represents the first 760,000 years of the universe's existence, compressed into a few seconds. This sound, while not an explosion or bang as many might expect, is a deep, throbbing rumble, a testament to the universe's early state of flux and formation. It's a sonic journey through time, offering us an unprecedented auditory glimpse into the universe's birth. John G. Cramer's project to sonify the Big Bang opens new doors to understanding our universe's origins. It transcends traditional scientific communication, allowing us to hear the universe in its infancy. This work not only sheds light on the physical conditions of the early universe, but also enriches our appreciation of the cosmos's vastness and beauty. As we continue to explore the universe, projects like Cramer's remind us of the creative and interdisciplinary approaches necessary to bring the cosmos closer to home. Don't forget to watch the video on the right and subscribe. Thanks for being part of Cosmoknowledge.